All right, folks, welcome back. So hopefully you took the time to watch the introduction to the series. You have an idea of what it is we're going to be tackling, and I hope you're excited about it. I'm pretty excited to bring this content to you. It was a learning curve for me, but I do have to give Cisco credit. This platform definitely is very capable. So without any further ado, let's go ahead and jump right in. So we're looking at the splash page for the Nexus dashboard for the admin console portion. So I had made mention of, I took the time to spin up 3 nodes. What we see here is node 1, 2, and 3. You essentially just deploy the virtual machine, power them all on, and then you have to run through the initial wizard where you'll provide the IP address. And once you essentially cluster, you have to cluster the 3 together, and they'll ask you a series of questions like this data network address, this management network address, which services do you want to activate, all that good stuff. So it takes a little bit of time, but once you do that, the 3 nodes should go healthy, which we see here. They're all role primary, they're active, green, and happy. They do consume a lot of resources, like I said. That's why I have them running in their own cluster outside of EVNG. But for all intents and purposes, we're not going to be doing anything under the admin console. We're going to be focused on the fabric controller. So when you click the drop down on the admin console, once the service starts for the NDFC, this will appear and you can click it, and this will effectively take you into the fabric controller. Once you're in here, this is where we're going to spend the majority of our time. So they give you a similar overview page. There's the topology, which obviously is blank. And then they give you this journey, which is kind of summarizing what I just said. So only thing I've done is activate the service. That's it. So what we need to do is we need to create a fabric. So we're going to go to Manage Fabrics, and we're going to go to Actions, Create Fabric. So it's going to ask you for what do you want to call your fabric. We're going to call it DC1 Eve Fabric, and then we have to choose what kind of fabric it is. So we're gonna touch on 3 of these by the end of the series, but for right now we just need to turn on our first fabric, which in our case it's a data center VXLAN EVPN. So it's a fabric for a VXLAN EVPN deployment with Nexus 9K and 3K switches. All right. So we're going to select that, and we're going to go through the motions here. So let me blow the screen up a little bit. All right. So if we go back to our topology, you'll recall that Data Center 1 was BGP 65001, and all the 10.1 subnets were affiliated with it, with the exception of that shared or stretched subnet. So all we're going to do on this first page is we're going to do 65001 for the autonomous system number. Everything else we're going to take the defaults. So it's just basically it's going to use OSPF to build the underlay to provide the reachability between all the loopbacks of the switches. It's going to use point-to-point /30 routed interfaces to do that. There's going to be 2 route reflectors because each spine is going to behave as a route reflector, and we'll leave the Anycast Gateway MAC we'll leave it at the default. For replication, obviously this is going to rely on the multicast side of the house. So the NDFC is going to configure any source multicast as the mode dictates here. It's going to provide redundancy with 2 rendezvous points, and they're going to rely on this subnet for the multicast traffic. Now in our case, the topology doesn't call for any virtual port channels, so we're going to skip over this. Protocols, again, this is where you would turn on authentication if you want to do so. You can change the name of the OSPF process or the area, all that good stuff. We're going to leave all the defaults because I want to demonstrate how easy Cisco has made it to essentially do a greenfield deployment here. Security, we're not doing a thing in here. This is for MACsec stuff that we're not going to rely on the lab to do. Under advanced, there's going to be a few things we need to pay attention to here. So for EVNG, there's a point of contention with the Nexus 9Ks when they're running in EVNG. They don't like jumbo frames, and if you want to run jumbo frames, you have to allocate some TCAM space, stuff like that. There's 3 hardware configuration statements that you would need to put into the switches, which require them to be rebooted. I'm going to try to avoid that, and I'm going to just say that the MTU is 1500. So we'll see. Hopefully we won't have any issues with that, but we're going to give it a shot. All this, okay, so VXLAN OAM, the feature, the switches that I'm running, maybe it's the versioning, whatever, it does not like the feature OAM. When you try to enable it, it fails. If this is enabled, the deployment from NDFC to the switches will try to activate that feature, which will inherently fail and cause the deployment to fail as well. So we're going to turn that off. We're going to leave everything else here default. This greenfield cleanup option, I want to enable this. It says that when you enable, the switch configuration will clean itself without a reload, okay? It will basically just rely on a bunch of no statements to remove anything that it doesn't want or need. If you have it disabled, then it'll essentially reboot your switches, which I want to, again, try to avoid that because of from a resource perspective. Okay, everything else on that page, we're good. We're going to leave. Freeform. Freeform is basically if you want to preserve anything inside of your config, you need to put that code in one of these text boxes, and it will preserve that code. In our case, we don't care. We're just going to flatten the switches, and we're fine with that. For the resources, I'm essentially just going to take all the 10.1 addresses. I'm going to start with the highest one, which is 10.1.255.0/24, and I'm just going to work backwards. These don't really matter that much. You can leave them as default. You can manipulate them. In my case, I just want them to be in the 10.1 space. So we have 255, 254, 253, 252. We'll leave all of the ranges the same. For a VRF Lite deployment, I'm going to change it to this. In a production environment, you'll most likely want to use that. And then this last range here, we'll make 10.1.0.0/24. We'll make it the very first one. Doesn't really matter. All right, so we'll save that. Oops, sorry. Manageability, we don't need to worry about DNS, NTP, or syslog for the lab. For Bootstrap, Bootstrap is indicative of, for the Nexus switches, they have the ability to do power on auto provisioning, or POPE. And POPE will essentially, when you plug the switch in, it will get an IP address from DHCP, which will point one of the DHCP options back to the NDFC, which then can essentially bootstrap the switch with a config of your choice. We're not going to do that. We're just going to have a simple management IP on our switches, username and password, and SSH enabled. With those 3 things, we should be able to import our switches, which will be the next step we're doing here momentarily. Configuration backup, we don't care. It's a lab. And last but not least, NetFlow, we're not going to worry about that because, again, it's a lab. So I'm going to save this. So once this saves, it should bring us back to the fabric page, and we should see a healthy fabric. It's healthy because there's nothing in it. Nothing's been done. We've just configured a bunch of options. That's it. Now, if we want to change any of the settings we were just looking at, if you highlight the radio button and you say Edit Fabric, it will take you back into that screen, and then you can X out or close from there. If you want to configure things within the fabric, such as interfaces, networks, VRFs, all the stuff that we still need to do, you double click into it. When you double click into it, now you're presented with different options, okay? So I want to highlight one more thing. If you single click it, it will bring up this kind of widget side view, if you will, and then you can hit the full screen button here and it'll take you to that same spot. So just kind of a quirk with the way that the graphical interface is set up. But at any rate, this point the fabric's been created and we want to get some switches imported into the fabric. So we're going to go to switches and we're going to say add switches. Okay. Now it's going to ask you for a seed IP address. So in my case, I've already got these management IPs applied to the switches. So I'm just going to choose one out of the bunch. I'm going to choose 176.61, which is actually leaf 1. Okay. And then I'm going to provide the username and password that I had configured on there. And last but not least, this preserve config checkbox. If you leave this checked, it's looking to do more of a brownfield migration from whatever's on your switches now to whatever you want to be on them through the NDFC. In our case, we want to do a greenfield deployment, so I'm going to uncheck this box. Then I'm going to press discover. It warns me that by unchecking that box, all of the configuration aside from management will be removed. Are you okay with that? Yes. Okay, so we can see it came back almost immediately with all 6 of our switches. So we should see 2 spines, 2 leaves, and 2 border gateways, which we do. So what we want to do here is we want to highlight all of them and we want to say add switches. Now this can take anywhere from 2 to 5 minutes. So what I'm going to do is I'm going to just kind of pause the video, and as soon as they come into, once it says switch added on all 6 of these, I will unpause and we will pick up where we left off. Okay, so we're back here. All 6 switches have been added, as we can see. So at this point, we just need to hit the close button. And what we have here is now we have an inventory. So the thing that we need to point out or highlight here is by default, once NDFC discovers your switches and adds them to the inventory, they're all going to show up as role leaf, which is obviously not correct. So if we go back to our topology, we should be looking at 2 leaves, 2 spines, and 2 border gateways. So all we need to do to remedy that is change their role. So I'm going to select both border gateways. I'm going to say action set role, and I'm going to say border gateway. Okay. It says, please perform a recalculate and deploy in the fabric to complete this change. I will speak to that in a minute. But in the meantime, let's change the 2 spines to be role spine, which is the top choice. It should present the same warning, which it does. Okay, that's fine. So what that means is, so we're inside of the fabric kind of view, right? So we're inside the fabric, we're configuring things, we're doing what we got to do. Under the top right, there's an actions drop down. So if you click that, it says recalculate and deploy. So every time you see that message from the NDFC, you need to do a recalculate and deploy. Now, take that with a grain of salt. You can make changes, which we will do here in a few minutes, without deploying every single step of the way. You'll learn like when you can do it, when you can't do it. But at this point, we're going to recalculate and deploy. So when I press this button, what the NDFC is doing is it is literally calculating the configurations on your switches, okay, based on their roles and the cabling that it saw the interfaces connected between all the devices. So it used Cisco Discovery Protocol. It finds out which device is connected to which. It knows how to configure those links based on that topology that it was able to figure out. And it's literally building the configurations for all the various devices as we speak. So by the time I got that explanation out, it's pretty much going to present the configurations to us, and it'll show us how many lines of code that it's going to push to the various devices. So what we see here is that for the leaf switches, okay, so leaf 2 is at the top and leaf 1 is second from the bottom. It's literally going to push 451 lines of code to those two devices. The border gateways are going to get, 332 lines of code, and the spines are going to get 338 lines of code. Now, if you want to see what it's going to push, you can just click this, and it will show you all of the stuff that it's going to do. So we'll see that it's going to basically turn on all the necessary features to make the VXLAN encapsulation and forwarding work. Okay, it's going to take care of the multicast that we had defined in the fabric settings, turns on the API, does some miscellaneous, things. It defines a route map that matches a tag. Here it's defining our BGP process, okay? It's actually activating the L2 EVPN address family, all right? It's doing the underlay OSPF, all right? It is defining the loopbacks with, you can see PIM enabled on all the loopbacks as well as OSPF. So it's got the two loopbacks defined. This is the network virtualization edge interface, which is really one of the key building blocks of VXLAN. So that's going to be used. I'm not going to go through every device, but you get the idea that the automation does a really good job of building the fabric. So at this point, all we need to do is hit the deploy button. So I'm going to go ahead and hit deploy all. Now this can take, again, anywhere from 2, 3 to 5 minutes, depending on, in this case it's a lab and I am taxing it a bit. So it's going to take a little while. So what I will do is I will pause the video once again, and once all of the executed commands are completed, we'll come back and we'll proceed to the next step. At this point, it looks like the execution was successful. So we've got some fully loaded configs with all 6 of our devices. So all we need to do at this point is close this. And what we want to see is all the switches should be in sync, right? There might be some operational statuses of minor, major, whatever. Typically, you'll get a minor for interfaces that aren't connected or a down state or whatever. So that's most likely what we're looking at. If you want to know what they are, if you go to Event Analytics, it will show you all of the alarms so you can see interfaces not connected. You can go ahead, you can select these and you can clear them by doing this. So you can clear all your alarms, and then when you go back to the overview page, it should go all green essentially. We're not really worried about it. It's not that big of a deal. So at this point, we created the fabric and we've imported our 6 switches into the DC1 fabric. The next step is to create a virtual routing and forwarding instance. So this is where the multi-tenancy comes into play. So I'm just going to call this tenant 1. I'm going to propose a VLAN. That's the power of the NDFC. You don't need to dictate anything. You can just have it tell you, yeah, use this. And when you do another VRF, it will just check to see what VLANs are in use, and it'll suggest one that is not in use. So pretty simple. We're just going to put that in for all the descriptions. For advanced, we'll go ahead and we'll lower that MTU again. We're not going to mess with any of the tags, none of that stuff. That's all fine. Tenant route and multicast, we're not worried about this. Route targets, we'll leave everything as is. Okay, and then we'll leave everything default. All right, so we're going to hit create. So it creates tenant 1, and you can see that it's a status of NA right now. So it hasn't been attached or being used or referenced anywhere. Now the next step would be, if we had VPCs or virtual port channels, we'd want to start to define those VPCs. But since we don't have any VPCs, we're only dealing with basic interfaces. If we go back to the topology, what we want to do next is prep our interfaces for what they're going to be used for. So in our case, port 4 on both leaf switches is going to be in network 10.0.0.0, and port 5 on both leaf switches is going to be in 10.1.101. So let's go ahead and get those prepped. So if we come over to interfaces, we're at the fabric level under interfaces. So this is going to show us every single interface across all 6 of those switches. So at this point, we probably want to filter, right? So we're going to say interface equals Ethernet 1/4. We'll start with 4. Okay, so this displays all port 4 of each switch, essentially. So there's 6 port 4s. We're only concerned about the 2 leaf switches, okay? And what we want to change is, see, they're in trunk mode right now. We need to change this to be an access port, okay? So we're highlighting both leaf switches for port 4, and we're going to click Actions, Edit. And we're going to click the policy here, and we're going to change it to access host, okay? So we want to make it an access port. Let's just turn BPTU guard off, okay? Let's lower the MTU. Everything else we can leave as default. So save and next, let me just collapse my video for a second. So we're going to hit save and next. Save and next will take you to the next leaf port 4. We're going to change that to an access host. We'll turn BPTU guard off, change the MTU back to 1500, and now we see a save button. So we're going to click save. So we can see that it has been saved successfully. Now, you can, a couple minutes ago I said you can press the deploy button throughout each of these processes, but you don't necessarily have to. So in this case, we are going to skip the deploy for the moment, okay? I'm just going to hit the X. So what we see is leaf 1 and leaf 2 have a pending change, okay? But you can see now they're access ports. So that's what we just took care of. Now we need to do the same thing for the 1/5. So we're going to say interface equals 1/5, or sorry, Ethernet 1/5. So let's filter all 6 switches. We should see 6 port 5s, which we do. We're only concerned with the 2 leaf switches. So same story, we're going to edit, turn them into access ports. Collapse my video one more time, save and next, then access port for the next one. So false, default, okay, and we will hit save. And we're going to skip the deploy one more time, and we're just going to hit the X. Okay, so same thing, right? We see 2 pending changes now for port 5, okay? So let's go ahead and we'll do the deploy now just so you can kind of see it, and then we'll do the next step. So if we come up to the top right and we say recalculate and deploy, let's see what it wants to do just by us changing those into access ports. So 21 lines of code go to each leaf switch. So let's check it out. So all it does is on ports 4 and 5, it takes off the trunking and it replaces it with access, okay? So I'm not going to deploy that. I'm just going to hit close. That's fine. Now, the next thing we need to do is, now that we've prepped these interfaces in the topology for access ports, now we need to actually tell it, like, hey, what VLAN are you going to participate in? And that's where the network tab comes into play. So if we click on networks, there are no networks built. So we're going to go ahead and we're going to create a network. Now, in this case, I'm going to change it just because my network 30,000 doesn't really resonate with me. I'm going to make it 10.0.0.0.24. So that's kind of indicative of the subnet, okay? I'm going to copy that to my clipboard. I'm going to tell the NDFC to tell me what VLAN. The VLAN I don't necessarily care about, okay? I could make this VLAN something that of my choice, but I'm just going to let NDFC propose that to me. This is where the default gateway needs to be defined. So in this case, it should be 10.0.0.1/24. That's going to be our default gateway for that subnet. For the name, I'm going to paste that description in, and for the MTU, I'm going to make sure I set it to 1500. So I'm going to create this, I'm going to go to advanced. This is that point of contention with ARP suppression. I'm going to leave it off, but typically I'm hearing that you're going to want to turn it on. It will rely more on like the cached ARPs on the switches, so it'll cut down on some of the bum traffic. That's what I'm hearing. For purposes of this lab, I'm going to leave it off, but in production, I'm getting the sense that you want to turn that on. Okay, everything else here I'm going to leave, and I'm going to hit create. So that creates the network for 10.0.0.0. So let's create the other. We actually need to create, in reality, we need to create 10.1.101 and we need to create 10.2.101. So we're actually going to create both of those now, okay? So let's create another one. And by the way, let me close this. If you select that and say export, it'll export it as a CSV file. And then what you can do is you can create, copy the row that it has in the CSV, paste it, and just modify the CSV. So if you have like 100 of these and you're proficient in Excel or maybe Notepad++ or something like that, and you can modify the values somewhat quickly and efficiently, that's a kind of a poor man's version of automation to get more subnets in here faster. For us, we're only defining 3 networks, so we're just going to do them manually. So this is the 10.1.101. We'll propose the VLAN. And by the way, the fabric settings, when we defined step 1, started at 2300 and go up from there. So that's why it started at 2300 and it's working its way up, just to be clear. So that's going to be our default gateway for this subnet. And let me just collapse my video because I don't know if you guys saw this the last time. So under advanced, we're not going to do ARP. We'll leave everything there. So we'll leave all these settings. We can always come back and modify this later if we want. For now, I'm just going to leave everything default. But the create button is down here on the bottom right. It was behind my video, so I just wanted to make sure you guys saw that. Okay, so that's our second network. Let's just add our third, and we are probably ready to deploy from that point. 10.2.101.0/24. So that's going to set us up for our network in DC2. I know we're not there yet, but we might as well just create it while we're here. Okay, so all that, we know advanced, we're not modifying anything, so we're just going to hit create. All right, so now we have 3 networks. All right, we can see they're attached to VRF tenant 1. So if we go back to the VRF, okay, nothing's changed from a status perspective, but we know that those are attached to tenant 1. So if you had multi-tenant and you needed to reuse the same exact IP, you should be able to do that since they're, going to different VRFs. At this point, we need to attach these networks to our topology. All right. So what we can do is if we select all of them and we can say multi-attach, okay. So in this case, the NDFC is only aware of devices in DC1. So once we spin up the fabric in DC2, we should see more devices populate and we can attach things as needed. So I just wanted to make that kind of clear now, as we only have devices in DC1. Now, we're not going to attach them to the border gateways yet. We will in the future when we do multi-site, but for right now, we're only going to attach those networks to the 2 leaf switches. Because again, the topology is indicative of the devices are only communicating through the leaf switches, so that's where we're going to attach the networks. Okay, so we're going to select both leaf switches. We're going to say next. Now, it brings up this page. It says, okay, well, the network 10.2.101, we know that's going to go in DC2, so we're not concerned about that one. So we're going to skip that. 10.1.101, we know that that's going to get attached to port 5 on both leaf switches, okay? So for this one, if we say view interfaces, we're going to say port 5, and that's for leaf 2. We're going to save that, all right? And then let's do the other 10.1.101. So this will be port 5 of the other leaf switch, okay? And then for the 10.0, right, we're going to attach that to port 4 of both leaf switches. All right, so we save that. And this, I think you can see it just to the right of my video, bottom right, but everything down the bottom right is like the save or next as I'm calling it out. So you can see the next button is kind of there to my bottom right. So we're going to hit next. And it says we can deploy, it says proceed to full switch deploy recommended. So let's go ahead and do that. Let's hit save. Okay, so now it's looking to push 113 lines of code. So let's check it out. So we knew about this, right? We already knew that it was going to change 4 and 5 to an access port. That much we knew. But now it's attaching the appropriate VLAN numbers based on the networks that we built. It's also doing the VLAN to VXLAN mappings, okay? So it's taking care of that for us. It's doing the route target import export under the VRF, okay, which is awesome. It's turning up the interface VLAN or the SVI, okay? You will see the IP address further down. Right there, it's just doing the interface VLAN, putting it in the VRF. And this is for the shared layer 3 VNI because it's got IP forward on it. It's doing the BGP, so it's taking care of our L2 VPN, EVPN, address families. And for the network virtualization edge, it's attaching our VNIs to the MKS group, which is proper. Here's the VLAN to VXLAN mappings, okay? Then it's doing the actual IP address for the default gateway with the tag, and it's declaring it as an Anycast gateway. So that gateway is going to live on both switches. It's kind of like the old school HSRP, but just envision that you had 12 leaf switches in your fabric. Every one of them would have that Anycast gateway, and you would have true redundancy, okay? And then last but not least, it's doing the EVPN. So that looks good. We're going to go ahead and deploy all. So it doesn't look like it's taking too long, which is good. Okay, awesome. So we got success on both, so we're going to close this. So now we can see that under the networks, so now the VRF shows deployed, okay, which is awesome. The networks all show deployed. And if we were to go into the interfaces, okay, and we do a filter, we should see okay, so now we can see that port 4 on both leaf switches has this network attached, which is what we want to see, okay? So at this point, if we go to leaf 1, well actually, let's go back to our topology. Let's fire up the two 10.0.0s. Okay, so show IP 10.0.0.11/24 with a gateway of .1. And let's go over to this guy. Okay. And then from our leaf 1, if we do a show MAC address, okay, so we see a MAC address hanging off of port 4, which is 6803. which jives with the virtual PC emulator. So that's promising. Let's go to leaf 2, show MAC address. We're seeing 6812 hanging off port 4. 6812. So that looks good. Now, the true test is let's try to ping our default gateway. Okay, so we can ping our default gateway. That looks good. How about on this one? Okay, perfect. So you can see it's not the fastest thing because, again, the lab is just getting its butt kicked. There's not much I can do about that, unfortunately. We might see some inconsistencies with pings. I'm just putting it out there. But at this point, we can see, so let's go back to our leaf switch, and let's do show MAC one more time. So this one here, right? 6812 is this MAC address on port 4 of the other switch. So you can see that leaf 1 is learning that MAC address, okay, through its network virtualization edge interface, and this is the IP address of the other leaf, okay? So if we do show IP interface brief, all right, we can see that 254.1 is right here, okay? So that's indicative of our NVE and our VXLAN encapsulation working properly, is that the leaves are now exchanging layer 2 and layer 3 information. And that's because of BGP. So if we show BGP L2 EVPN summary, we can see that leaf 1 has 2 neighbors, so spine 1 and spine 2. They've been up for 22 minutes since we started this process together. And they're learning, it's learning 5 prefixes from each of those, okay? If I get rid of the summary, now we see some more information, okay? So for instance, we had seen, you know, that 6812 MAC address. We can see that we're learning both layer 3 and layer 2 information, and that's again because of the L2 EVPN address family with the BGP peerings. So this all looks very good. So at this point, so if we go back, right? So at this point, what was this? This was 45 minutes, and this is me saying it before I cut out any dead air for deployments and stuff. So we've literally configured a single site VXLAN fabric with 6 Nexus switches and 4 nhosts in less than an hour, which I think is pretty impressive. And it, you know, the tool is basically ensuring that nothing is wrong. It's ensuring the consistency. So I'm very impressed, and I was super excited to kind of bring this to you. So I think we're at a good point to stop. The next video, what we'll do is we will configure DC2 because it's a little different with the spine doing double duty. So we'll get DC2 going on the next video, and we'll just continue to build upon everything from there. So I appreciate you guys watching, and I will hopefully see you on the next video. Take care.